Continuing with aldehydes and ketones, now I'm going to do several videos using syntheses or sequence of reactions, applying reactions of aldehydes and ketones, but I'm going to be using also reactions of alcohols and say substitution, elimination. So we're going to combine things into a synthesis problem. So I'm going to see what is here that I have prepared. So I need to make the following molecule. And so I have an aldehyde here, and I need to make this with a carboxylic acid. So we're gonna figure out a couple of ways here that we can do this reaction. So we need to start from the following molecule, which already has an aldehyde here, but I have a bromine. So one way we can do this, notice that I need to use a reagent that adds one more carbon to the chain. So I'm going to do a couple of things. First, I could do the reaction with, say, sodium cyanide. Problem is that here, this reagent could also attack here and do the cyanohydride. So because of that, I'm going to use a protection here. So I want to do an SN2 over here and introduce the nitrile, but I don't want that to be touched. So prior to do that, I want to protect this group. And here I am using an acetal. So the acetal formation will allow me to protect this functional group. So now I have this. So I wouldn't do that directly again because I don't want the cyanohydrin to form. I'm going to draw the product. If I did that, say that I had an excess. I have a couple of things that can happen. I could have the cyanohydrin here. And I didn't want that because I want to make that. I could also substitute here by a nitrile. So that will be a problem. This one, after hydrolysis, can give me the carboxylic acid, but certainly I don't want that in the carbonyl. So this is why we want to protect the carbonyl. So now, once that I have that group protected, then we need to remember the acetals, and that's a cyclic acetal. These are stable under basic conditions. So I can use sodium cyanide. They're stable on basic conditions, and they will hydrolyze back to the carbonyl under acidic condition. So I don't want to use acidic condition. So, but I can use this neutral. Typically, this reaction we use HCN like a buffer thing, but we can keep it as neutral as possible. The idea is that I only do a substitution of the bromine. So if I do that reaction, in what will be what I'm doing here? Plus, negative. So I'm going to do an SN2 reaction over a secondary alkyl halide. The secondary slower than primary, yes, but still the reaction will proceed. So I'm going to do the acetal being stable under basic condition, basic and neutral. I'm going to have the formation of the nitrile here by the SN2 reaction. Next thing that I can do is, if I want that, I will simply, in one step, I'm going to do the hydrolysis of the nitrile to the carboxylic acid, and the acetal will hydrolyze back to the carbonyl. So that is one step using this is a hydrolysis. In this time, I want acidic conditions. Again, hydrolyzing that to the carboxylic acid and removing the protection. So hydrolyzing the acetal to the carbonyl. That will get me there. Okay, there's another way that we can do this. And that also, I'm going to need protection. So my plan is now adding one more carbon, doing Grignard. And because I have here an alkyl halide, so I'm going to do another pathway, and I'm going to start here. So I'm going to start with the already protected acetal, the cyclic acetal protecting the carbonyl. So I'm going to redraw that molecule over here with the protection, so the cyclic acetal. So first step being the same, right? So I'm going to have that. And once that is protected, I can make this react with, say, magnesium, and this is dry ether, diethyl ether, and I will make a Grignard reagent. Still, these conditions are basic when I'm making Grignard. This is MgBr, right? And this is still stable. We can do Grignard, acetals with Grignard, and these will stay like that. So once I have that Grignard, I can make it react with, since I need only one carbon, I'm gonna make it react with carbon dioxide. And so now, simplifying things, we're gonna say plus a negative here, and I'm gonna do a nucleophilic attack over this. And now I have the following, is still keeping my cyclic acetone. And here I have now a carboxylate. And in one step, I can do protonate that and do the acetal hydrolysis, so acidic conditions. And I'm gonna add, say, H3 plus, so hydrolyze, protonate this, and hydrolyze the acetal back to the aldehyde. So here we have two paths that we can use to synthesize this molecule from this one here.